a horizontal, a vertical, and a domain together, then you could try a vertical, a horizontal, and a domain on your own, right? For this part of time. So let's see, horizontal. I'm going to compare the degree of the numerator and the degree of the denominator. So the degree of each one is just 1, right? These are both linear functions. So what do? I strip the coefficients in front of the x's themselves. So this is really 1x over 1x. 1 divided by 1 is 1. So my final answer, I have a horizontal asymptote at y equals 1. First, I had to check the degree. They were the same. So that on our note card is rule 4, I think 4b, right? The numerator is equal to the denominator. So I strip or I peel off the coefficients. 1 divided by 1 was 1. So the second question is the vertical asymptote. So now I go to my note card. What does your note card say to do? Set the denominator right here equal to 0 and solve for x. What would x have to be to make that true? Yeah, if I plug in -2 for x, don't I get 0 in the denominator? Subtract 2 to the other side. So I write my asymptote x equals -2, right? What makes the denominator equal 0? Right? And the third one that I wanted to do with you, I'm just going to skip down to question number 4, and then you can try 3, 5, 6 for a minute. So the domain. Look at step number 3 on your note card. Vertical asymptotes also help you find the domain of the function. Did we write the word domain on our note card under step 3? I thought we did. Maybe you want to circle the word domain, or next to step 3, vertical asymptote, write domain on there. So if it's step 3, again, I'm looking at the denominator. This is a quadratic. What do I have to do to the quadratic to find my domain? Factor it. So this is a trinomial. So I want you to factor your denominator. Take a minute and try it on your own, right? It's a trinomial. So you need the diamond method, right? The factors of 2 that add up to -3. Factors of 2 that add up to -3. And then once you have your factors, see if you can figure out your domain. So I'm looking for the factors of 2 that add up to -3. You should have chose -2 and -1. So x minus 2, x minus 1. This is page 206. You with me? What will make those values equal 0? +2 and +1. So my vertical asymptote, I would write x equals, but this is a domain question. So I'm going to write x can never equal 2 or 1. So you write your domain different than how you write a vertical or horizontal asymptote. All right, I'd like you to take a couple minutes, try 3, 5, and 6, because we just went over one of each of those. If you want to keep us moving a little bit, number 3 is a little bit of a trick question. You look at your denominator, x squared plus 4. Can that ever equal 0? You may have tried, right? You may have tried to subtract the 4 to the other side, but when you try to take the square root, a square can never get you to -4. So this will never equal 0. Like I could plug in 0, I'd still get 4. I could plug in -2, I would get 8, right? So there are none for number 3. Sometimes the denominator cannot equal 0. So in this case, right, you've got a quadratic that's positive sitting in the denominator. Does that have any possibility of equaling 0? Think about the original graph of this parabola has been shifted up 4 units, right? It has no x-intercepts. It will never equal 0. It's prime. Okay, so that one is a none. Number 5, horizontal asymptote. You say in your brain, okay, the degree of the numerator is 2 and the degree of the denominator is 2. Those degrees are equal. So you use 4b on your note card. When they are equal, you peel off the coefficients. So 3 over 1, right, is y equals 3. Horizontal asymptote, y equals 3. All right, number 6, domain. I go back to my denominator. This is a quadratic. When will x squared minus 10 equal 0? And I know a lot of you took trig, so x squared minus 10, I would add 10 to the other side. So x squared equals 10. Sometimes you don't get a perfect square, right? But I can still take the square root of 10, like when you had to reduce radical form and stuff. 10 is already in reduced radical form, so my answer is just plus or minus the square root of 10. And that's harder than one that I would give you. I'll probably give you one that's factorable, like difference of squares. But plus or minus root 10 was the right answer if you got there. So let's see. Let's do 7 and 8 together. And maybe 10. Let's do 7, 8, and 10. And then you try 9, 11, and 12. So I'm choosing 7 and 8 because they're about intercepts, and 10 because it's a slant asymptote. Then you try 9, 11, and 12. So let's see. Real zeros. On your note card, if you don't know what a 0 is, you're going to want to write down next to number 2 that an x-intercept is the same as a 0, right? We've been using them interchangeably, but if you get confused and you don't know what a 0 is an x-intercept. So you're going to use choice number 2 on your note card. What do I do for choice number 2? I look at my numerator, right? So I'm asking myself, where does this numerator equal 0? This is a difference of squares, x squared minus 9. So I factor it. What does it factor into? Yep, x plus 3 and x minus 3 has to equal 0 on number 7. Sorry, I kind of ran out of room, so I'm down here below the problem. What are my two x-intercepts then? One will be at -3 and one will be at +3. And the way that you write an x-intercept is -3, 0 and +3, 0. They're written differently than a vertical asymptote. So number 8 says find all of the intercepts. So find the x-intercept and find the y-intercept. We haven't done a y-intercept yet today. That's rule number 1. How do I find a y-intercept? I plug in 0 for x. When you plug in 0 for x, what do you get? So I get -16 divided by -9. I can just leave that as 16 over 9 if you don't want to use a calculator. I don't know what that is in my head. 1 point something. All right, what are my two x-intercepts? So this time you're going to look at the numerator. The numerator is almost the same as the previous problem. It's just x squared minus 16 this time. What is x squared minus 16 going to factor into? Yep, so equals x plus 4x minus 4. So what are the two x-intercepts that come out of those parentheses? -4 and +4. So 4, 0 and -4, 0. So I get two x-intercepts and one y-intercept. And then the last one that I'll do with you, because it's a slant asymptote, then we've kind of touched on each of the rules, and maybe you could try 9, 11, and 12. And I think for after lunch, maybe I'll make you like a practice quiz so you can see like, this is the format of the quiz, here's my equation, here are the questions that I'm going to be asked, and then I have to graph it with my note card. So almost like after lunch, you take a practice quiz. I was going to do the refrigerator problem, but I think you just need more practice first on using the pieces of these functions. So Slant asymptote. First of all, how do I know that I have a slant asymptote? What's the degree of the numerator and what's the degree of the denominator? Quadratic over a linear. This guy wins. When the numerator is bigger, on our note card, I think that's rule 4C that we wrote down, right? Numerator is bigger, do division. You might need a little bit more room. I don't know. But we're going to do division using this x minus 1 down the side. So x minus 1 goes down the side. And then 3x squared goes inside my box. So I'm going to put 3x squared. So what's the first term? This is going to be my quotient up here. What's the first term of my quotient? 3x, yep. So 3x goes at the top. And then I multiply to get the bottom box, right, which would be negative 3x. So there it is. What do these two boxes have to add up to? So I look back to my original problem over here. It was positive 2x's. So I have negative 3x's. How many x's do I need? Oops. No water. Don't worry, just water. But of course the lid. Did I get your stuff wet? It's just ice. It's fine. I'll pick it up in a minute. Oh, thanks. I'll probably. Okay. So I would have 5 x's. Right? So I have a negative 3x and a positive 5x. As long as it doesn't short out my computer. Huh? What? Really? It's going to zap me through the adapter thing, is it? Oh, well, I didn't get electrocuted. Whew, live another day. All right, so let's see. Plus 5 would be the last part. I just wanted to get it to so that you could try them on your own. Here you go. Then I'll pick it up. So y equals 3x plus 5. I don't really care about the remainder, but if I wanted to find the remainder, right, you multiply, you'd get negative 5 down here. To get to negative 1, you'd need a remainder of 4. But y equals is how you write it, 3x plus 5. So make sure after you do all the work on the quiz, you actually write it out as a asymptote. Y equals 3x plus 5. So now you're going to try 9, 11, and 12 on the